Hello, Rich Alverson here. This is ITS128. And in this video, we're going to do chapter 7 on loops. So let me share my screen. It's number screen 1, screen 2, I guess. Switch. Okay, here we go. So, okay, so loops. So let's start here. This first section just helps you understand the concept of a loop. And you can go through this. It's basically you you check to see if a condition is true or false. If the condition is true, then you execute this patch of code. And then when you're done executing that patch of code, you go back and you do the check again. You check to see if the condition is true or false. If it's still true, you do the loop, you execute the patch of code again, and so on until the condition that you're testing is false. And so you can go through this. It's pretty straightforward. Look, here's an example. Click increment if a negative value is seen. So I guess you're supposed to do this faster. Okay, so no, there it is. Increment. Okay, so that's correct. Find the maximum value. This is a little bit different because each time we're going to check and see if what we're looking at is bigger than the max, and if it is, we're gonna copy that over into max. So here at 95, we're going to store the value. Max 21. No, we're not going to store that one. No, we're not going to store that one. Not that one. Not that one. Not that one. Not that one. Okay, so that's the maximum. Let's do this again. Whatever. Okay, let's start again. Store the first value, and then yes, it is. Store that one, next one. No. So let's store that one, next one, next one, next one, next one. So that's the highest one. See, so that's another example of a loop and testing each time. And basically with this, inside the loop, you're testing to see if the maximum that you have stored is still bigger than the one that you're looking at. And if the max that you have stored is not bigger than the one that you're looking at, then it replaces max with the bigger one. Okay, but as far as the loop is concerned, it's just going to go and look at every single one. So it's going to be 1, 2, 3, 4, 5, 6, 7. It's going to test it 6 or 7 times, 6 times, because it's just going to store that one, and then it's going to test this 1, 2, 3, 4, 5, 6, and it's going to test all the way until it's done with things to test, and then it's done. So, okay, so the first kind of loop we're going to look at is a while loop. If we look over here, we can see that we're going to do while loops, and then we're going to do for loops. Okay, those are the two kinds of loops. So here's how the while loop works. Okay, the while loop looks just like an if statement. Looks just like an if statement, except for instead of the word if, we have the word while. And the other difference between an if statement and a while statement is with an if statement, you test the expression. If the expression is true, you execute the body. That's how an if statement works. That's how a while statement works also. But with a while statement, when you're done executing the body, you go back up and you test the expression again. And if the expression is true, continues to be true, then you execute the body again. And you're going to keep on executing this body as long as this expression is true. So there needs to be something inside the body that'll eventually make it so the expression is false. Because if it never happens that the expression is false, then you're in an infinite loop, and it loops forever. Okay, so and you don't want to be in an infinite loop. So so that's how a while loop works. It's just like an if statement, except for you go back and you test the expression again when you're done executing the block. Once you test the expression and it's false, then you skip over the block and you can continue down here beyond the block, which is just like it is with an if block and if an if statement. If the if is false, then you continue on. You skip the block. You do not execute the indented block, and you continue execution after the while statement or the if statement. So here's an example where you're defining a variable called the current power equal to 2, and you have another variable called user character or user char, and that's equal to y, the letter y. And then you have this while loop. While the user underscore char variable is equal to lowercase y, then do these three things. The first thing prints out the current power. The second thing multiplies the current power by 2. And the third thing, it reads another user char. So it's not going to be the same user char. It's going to be a new one that you read, okay? And so then it's going to come back here and it's going to test this expression with a different user char now because you just read a new one here. And you're going to keep on doing this loop until the user types in a something that's not a y. So as long as the user types in a y, it's going to do the loop until the user types in something that's not a y. In this case, the user typed in an n, so it's going to loop 3 times. The first time it's just set to y, so it's going to do that once, and then it reads this y, it does it again, and then it reads this y, it does it again, and then it reads the n. So this ends up being false. So it skips out and goes here. Okay, so that's how this works. You can click through that. All right, you can answer these questions. This is a kind of a dumb thing where it prints out a face. Whatever. Let's do some of these things. What is this? While loop step by step. Okay, so we're going to start out. User enters the number 902, and it takes the mod of 10, which is going to break off the 2. So we end up printing the 2, and then we integer divide by 10. So now num is equal to 90. We see that here. And then we go back up here. Is num greater than 0? Yes, it is. So we're going to do another iteration. And so it does another iteration. Hacks off the 0. Now we do this integer divide again, and we end up with 9. Goes up to the top here. Is 9 greater than 0? Yes, it is. So do another iteration. 9 greater than 0. Yes, it does that. Hacks off the 9. Then it takes num divided by 10, and we end up with 0. And then we go up here, and it's num greater than 0. No, it's not greater than 0. So we're done. Okay, anyway, so you can go through this. Let's see if there's a challenge. Here's a challenge. Let's do this. Good, I hope we get through today. All right, so let's start this out. G is equal to 0 while G is less than or equal to 3. Print G. Okay, so G is equal to 0. Is G less than or equal to 3? Yes, it is. So we're going to do these two things. First thing we're going to do is we're going to print G, which is 0. And then we're going to add 1 to G. So now G is equal to 1. Is 1 less than or equal to 0? Yes, it is. So we're going to print that G. And so now we're going to print 1. And then we're going to add 1 to G. Now G is equal to 2. Let's go back up here. Is 2 less than or equal to 3? Yes, it is. So we're going to print the 2. And then we're going to add 1 to the 2. And now G is equal to 3. We go up here. Is G less than or equal to 3? Yes, in fact, it's equal to 3. So we're going to print the G, print 3. Here we're going to take G equals G plus 1. So now G is equal to 4. So then we go back up here. Is G less than or equal to 4? No, it's not. So then we skip out. So we're done. So let's see if this is correct. Yes, it is. All right, so this is pretty easy. Here we're doing G starting with 0, and we're going to check each time to see if G is less than or equal to 5. Okay, so the first time we're going to go through, we're going to print the 0. Then we're going to add 3 to the 0, so we have 3. Is 3 less than or equal to 5? Yes, it is, so print the 3. And then we're going to add 3, and we have 6. Is 6 less than or equal to 5? No, it's not. So we're done. Okay, let's do one more. Now we're going to start with G equal to 0. And while G is greater than or equal to -2, we're going to print G. Each time we iterate, we're going to subtract 1 from G. So the first time G is equal to 0, the second time G is equal to -1, the third time G is equal to -2, and then after that, if G is equal to -2, it's going to print the -2, but then after that, G is going to be decremented by 1, and it's going to become -3. In that case, it's going to fail. So we're going to see it printing 0, and we're going to see it printing -1, and we're going to see it printing -2, but after that, we're done. Yes. Okay, very good. You could do the rest. Let's do this one. A while loop reads integers from input into a variable n, into a variable called this, value in. Write an expression that executes the while loop while a non-negative integer is read into value in. Okay, so so we're going to read value, and it's going to be an integer. While it's not, while it executes the while loop while a non-negative integer is read in. Okay, so while value in is not is while it's non-negative. So while it's non-negative, which means it's greater than or equal to 0. While it's greater than or equal to 0, which means it's non-negative. It's 0 or above. It's not below 0, it's 0 or above. Then print it out. And then read another one. So it's going to keep on doing it until somebody right here types in a negative number. See if that works. All right, very good. Let's see what the next one is. Okay, so in this one, this thing is read in. There it is. Write a while loop that reads in values from input and casts the values into integers. Yeah, that just means, well, this is what casting values into integers does. So we're going to make a while loop here. While the integer 1 is not read. While num in is not equal to 1, while num in is not equal to 1, while the integer 1 is not read, then we're going to do this. So what that is going to be is update in sum with the sum of in sum and in. Okay, so we have in sum here. Okay, so update in sum, int sum. We're going to add to int sum num in. Okay, and then we're going to read the next integer from input into the variable num in. So basically, we're just going to do this again. Yes, okay, so let's see if this is correct. All right, very good. Okay, so you can do the last one. What's next? More while examples. Okay, here's an example of finding the greatest common divisor. And this is a pretty famous program, so the sooner you sort of ingrain this in your brain, you're going to see it more probably this semester and maybe next semester and maybe the semester after that if you continue taking programming. Um, you use the greatest common divisor program to come up with relatively prime numbers, so you can create public keys for you know encryption and all that. Here again with a while loop, you have to ensure that sooner or later the loop is going to end. And so here what we're doing is we keep on making num A and num B smaller and smaller until they end up both equaling 1, I think is what happens. Or until they're equal. So you can run this if you want to. So this finds the greatest common divisor between 20 and 15, which is 5. 5 goes into 1 goes into 20 and 15. And 5 goes into 2 does not, 3 does not. How about let's see. How about 50 and see 50 and 40 would be 10, I guess. Is 50 and 40 would be 10. Anyway, so this just so you can run some examples and answer these questions. This is just a go through these examples, get the points. Which if-else branch will execute if these are types goodbye? You can go through and make sure you understand, make sure you can follow the code. Are there any challenges? Okay, here's a challenge. The while loop with the sentinel. This is okay. So the way a sentinel, what a sentinel is you're reading a bunch of numbers, and you're going to have a special input number, which means it's the end. And in this case, the sentinel is 0 because the loop here is while the current value, you read in the current value, and then you read in the current value again down here at the end. At the end of this loop, you read in the current value again, and you keep on reading the current value. It keeps on doing this until the current value is less than or equal to 0. And in this case, as soon as it gets to be 0, as soon as you try to input 0, then this loop terminates and goes down here and says what the maximum value is. What this program does is it finds the maximum value of all these numbers that were input. Okay, so each time it loops, it reads in another number. It checks to see if the number that you just read in is bigger than what we have so far as the maximum number. If the new number we read in is bigger than the maximum number, then we want to store that new number as the maximum number. Otherwise, we don't want to do that. See, so if the current value is bigger, then we do it. If it's not bigger, then we skip it, and then we read in the next value. And we do this until we reach the sentinel value, which is not really part of the data. It's an indication that there's no more data. So let's start this up, and we're going to say we're going to see what we write out, and each time we're going to write out, we're going to read in, and we're going to do this loop. We're going to keep on doing it until we output the maximum number. Well, I'm just gonna say this, 9, enter, is that one? Oh, we're gonna print max value. We're gonna print that out because this is gonna loop through and it's gonna store the maximum value. And it's gonna end up storing that one because it's gonna, each time it reads in a number, it's gonna test this and it's gonna keep on replacing the maximum number with the new maximum number if the value read in is greater than the maximum number. So here the maximum number is going to be 6. Here the maximum number is 7. Here the maximum number is still 7. Here the maximum number becomes 9. Here the maximum number is still 9, and then we're done. So that's what the answer is. Let's see if this is correct. It is. Let's do the next one real quick. So here it looks like we're just summing up these values. Sum starts at 0, and we're going to sum numbers until we reach a sentinel value, which is not part of the data. It's an indication that there's no more data. And here the sentinel value looks like it's anything 0 or low or less. This is 0 or less. So it's going to read in the 7 and the 2. It looks like it's just going to add them up, and it's going to print out sum colon is 9. You really should go through this loop and play it out in your head, but if you know what it's doing, then you can just do that. All right, let's do this. Ooh, a lot of challenges. Let's do this challenge. Bidding example. Variable keep bidding is initially assigned with a y. Within the while loop, keep bidding is updated with the user's next input value. Complete the while loop's expression to terminate the loop if the user enters an n. Okay, so the user actually has to enter an n. It's not that the user types in something other than a y. The user actually has to type in an n, or at least that's what it says here. So that goes right here. Okay, so keep bidding is equal to y. Here we input another keep bidding. Here we do some bidding. And here we ask the user, do you want to continue bidding? And this is just bidding random numbers here. Okay, so we got to say if while keep bidding is not equal to n, while it's not equal to n, then you're going to keep on bidding. All right. I'm gonna type in the wrong, or I'm gonna make an error, and I'm gonna say while keep bidding is equal to y. Okay, because that's not quite right. While it's equal to y, that's not quite right. And what this does is, if you type in an n, it'll quit. If you type in a y, it'll continue. But really, that's not what we're asking for up here. We want the terminator to be anything other than, no, we want the terminator to be exactly n, not something that's just not y. Okay, so this should give me, I should not get all the points for this. Let's see. Oh, good. I'm gonna see what this says. Well, this is what it says, but that's not what I have. But I got all the points. That's no good. All right, well, anyway, let's do the next one here. A positive integer is read from input. Write a while loop that in each iteration first prints and then doubles num insects. Okay, so the loop executes while values are less than or equal to 100. So the terminator is positive integer is read from input. Okay, so first it reads a number, and then we create a while loop that each iteration it prints the number and then doubles it. And we're going to do this while the values are less than or equal to 100. All right, so let's see what happens. Each number does a new line. Okay, so I'm going to try to do something here. While num insects is less than or equal to 100, print the number of insects. Then double them. Num insects. I think I can just do this. Then 2 multiplied by 2. All right. So I'm gonna run this and see if it works. Ah, look, it works. Huh, very good. Okay. Here it's testing a boundary condition. And it's exactly 100 and it should print 100. It's testing if it's less than 100 or less than or equal to 100. If I were to do this, it would fail that test, you see. See? Ooh. Expected this and it didn't get it. So anyway, I got the points anyway. All right. Integer this is initialized to this. Input consists of integers that are experimental measures. Write a loop that iterates while num successes is less than 2. So okay, so I'm going to read an integer called current temperature. If the current temperature is between 15 and 59, then increment num successes. Otherwise, output the current temperature. While num successes is less than 2. So that's what this is. This is going to be while num successes is less than 2. While num successes is less than 2. While that's the case, we're going to read the current temperature. CURR temp equals int input. Read the current temperature if current temperature, I'm going to use this if 15 is between 15 inclusive 59, less than or equal to 59. If that's true, then num successes increment it and output current temperature. Print current temperature. I'm gonna get rid of this space just in case that causes me problems. Okay, all right. Okay, so let's see if this is it. Looks like I got it. All right. It wrote it this way. It thought this was the way to write it, but I wrote it this way. All right, let's do the next one. This is read from input. This is read from input, and this is initialized at 0. Write a loop that iterates while input item is not equal to completed. So I go while input item is not equal to completed, then in each iteration of the loop, read integer food stock from input. Food stock equals input. Increase sum counts by the value of food stock. Sum counts increase by the value of food stock. Okay. Output the value of input item. Okay, print input item. And then read a new input item. And while input item is not equal to completed, read in a food stock, add it to sum counts, print out that item that it just read in that was not equal to completed, and then read in a new one. Let's see what this does. Okay, it looks pretty good. All right, so let's go on counting. Commonly, a loop should iterate a specific number of times, such as 10 times. The programmer can use a variable to count the number of iterations. It's called a loop variable. Iterate n times using an integer loop variable I. A loop with the following form is used. So you can do it this way. First you set I equal to 0, and then you're going to loop while I is less than or equal to n. You do some stuff, and then at the very bottom you increment I by 1, and you go back here and you test to see if you've hit n yet. So, n's got to be defined, or should be defined beforehand. And you're iterating, n times. That's what this is. Don't forget to put in the thing that's going to make it eventually. Don't forget to put in the thing that's going to make it so eventually the loop will end. Okay, that's what this is. Okay, so here's a program which counts savings, and it's a saving interest program where we have initial savings of $10,000. The interest rate is 0.05, which means I guess every year you'll get 5% added to your savings. So here we're going to input the number of years, and so it's going to iterate that number of years. Starts out with year with I equals 1, and that's going to count the number of years, and this is the variable that reads in number of years. While I is less than the number of years, you output the savings at the beginning of the year. You add the interest. The interest is what your savings is times the interest rate, and you add that to your savings. That's the new value of savings, and then you increment to go on to the next year. And you're going to keep on doing that until you've reached the number of years that you want to do this for. Okay, so like 10 is going to be, start out with $10,000, 5%. You do this for 10 years, and you end up with this amount after 10 years. So you made, you have again your money. You start out with just $10,000, and now you got $15,513. It's compounding interest. So this is what happens if you compound interest every year. What happens if you compound interest every month, for 5 years or for this many years. Well, that would be the interest rate is 0.05 divided by 12. And the number of years is going to be the number of years that you read in times 12, because we want number of months. And so the interest rate is now months. Let's change this variable name to months, because we entered the years times 12 is months, and then we're gonna iterate over all those months. And let's see what it comes up with. So it's the same amount of money we're investing, but we're going to compound every month 1/12 of 5%. So instead of waiting for the whole next year to do the 5%, we're going to do 1/12 of the 5% every month, and at the end it should add up to. So okay, so let's see. If we compound it yearly, it ends up being, changes to beginning of month. Compounded yearly, it's 15,513. Let's run this. Ah, 16,401. So we made another $900. We compounded monthly. Well, that's why you want to compound it in as small increments as you want. We can change this to daily. So 16,401 if we compound monthly. If we compound daily, we make this divided by, let's do 365. 365. And let's make this 365. And let's make this day. This is going to go really long. Run. Oh, too many. All right. Forget it. All right. So you can answer these questions with the yearly interest rate thing. Let's find some challenges here. What is this? Use the following tool allows you to enter values for the loop parts and then executes the loop. Using the tool, try to solve each listed problem individually. The tool can use any relational or inequality operator. It can use any one of these, or this. Oh, these will not work. Is and in will not work. Okay, so we want to go from 0. I starts out at 0. While I is I don't know, less than or equal to 10,000. I equals I plus 500. Oh, plus 500. Well, okay. Nice. Cool. All right, you can fiddle with that. Calculate the factorial. You can fiddle with this. Okay, let me just follow this. A program that lets a user enter n and outputs n factorial. So use a loop variable I that counts from total -1 down to 1. So it counts from total -1. So loop variable I equals total -1 down to 1. So while I is greater than or equal to 1, while I is greater than or equal to 1, set total equals total times I, and then decrement I equals I minus 1. Okay, I think this is right. Okay, 5 makes 120, 8 makes 40320. All right, okay, 4 makes 224. All right, sorry this took so long. Anyway, let's move on. All right, so let's do this one. Okay, while n equals 1, no, n equals 1, while n equals print n minus 2, and n equals n plus 1. Okay, so n's going to go, n will equal 1, 2, 3, and 4. N will equal 1, 2, 3, and 4. So that means it's going to print 4 times. The first time it's going to print, each time it's going to increment n by 1. So first time it's going to print, what's 1 minus 2 is minus 1. And then it's going to print 0, because n is equal to 2. Then it's going to print 1, and then it's going to print 2. See that? The first time it's going to print 1 minus 2, and then it's going to add n. So then it'll print 2 minus 2, then it'll print 3 minus 2, then it'll print 4 minus 2, and then this is going to make the 4 equal 5, and then it's going to quit. So let's see if this is correct, and it is. Let's do one more. Okay, so this is, n is going to go first to 3, then to, so while n is greater than 0, so n is going to go 3, 2, 1. So it's going to be 3 times, 3, 2, and 1. The first time, 3 plus 2 is 5. And then it's going to be 2 plus 2 is 4. Then it's going to be 1 plus 2 is 3. And then n is going to be equal to 0, and it's going to stop. All right. All right, you can do the next one. Counting. Okay, so integer my input is read from input. This. Integer x is initialized at 10. That's this. Complete the while loop to perform the following tasks at each iteration until x is greater than my input. So while x is greater than my input, you want to do these things. Okay, so you want to output a colon. Start right. You say output a colon. Print. Output a colon. And then increase x by 2. X add to x2. I don't know what this is going to do. What does it look like? Oh, all right. Huh, okay, let's do the next one. Oh, down here. Oh, here we go. Integer user num is read from input. Initialize the variable x with 4. I'll initialize it with 4. X equals 4. And then write a while loop to perform the following tasks at each iteration of x. Okay, so while until x is greater than user num. While x is less than or equal to user num, while that's the case, increment x, and if x is divisible by 3, if x mod 3 is equal to 0, then print x. Yeah, this isn't that difficult. Yeah, okay, well, very good. Okay, for loops. All right, so okay, so for loops is actually a different kind of loop. It's a different kind of syntax, and what you have is a you have a container or something. A container, I guess, is one way to put it. For each variable inside the container, you execute the loop. Okay, so one nice thing about a for loop is that you're probably never going to run into a finite or an infinite loop. Okay, there's times when you can do an infinite loop, but I'm not going to get into that. Okay, but as long as you follow the basic rules of how a for loop works, you should never get into an infinite loop because you know how many times it's going to iterate before the loop even starts. So here's an example. What you're going to do is inside this block, inside the block underneath here, the value for the variable here, name, is going to, the loop is going to iterate 3 times because there's 3 different values for name. And the first time it iterates, the value of name is going to be equal to Bill. The second time it iterates, name is going to equal Nicole, and the third time name is going to equal John. So that's how this works. That's how a for loop works. So here you're doing for, and what we're going to call the variable C. Okay, so it's going to iterate through this list, this channels list, and this channels list has 5 items in the list. No, this is a dictionary. This dictionary is 5 items in the dictionary, and C is going to be the key. The first time C is going to equal that, then it's going to equal that, then it's going to equal that, that, and that. And this value here, channels of C, when C is equal to NBC, channels of C is going to equal to 4. When C is equal to MTV, channels of C is going to equal 35. So that's how that works. This iterates through all 5 of them in it's might not be this order, but I think in later versions of Python it is going to be this order. And so this is what it's going to look like. Okay, you can also iterate characters through a string. That's what this does. For each character in this string, T, then A, then K, then E, and so on. Character is going to, first time it's T, then A, then K, then E, and so on. So, we want the variable to be called my pet, for my pet. First time it's going to be Scooter, then it's going to be Kobe, then it's going to be Bella. Okay, so, all right, so this is a list. And so the 0th one is going to be this, the first one is going to be this, the second one, third, fourth, that's like that. Here we're going to loop through all of the revenues. Day for the first time is going to equal that. The next day, the second iteration is going to equal that, so on. So here we have looping over strings, lists, and dictionaries. All right. Here we got a list, and for each number, the list is called numbers. For number in numbers, print it. So let's start this up. So we're going to print each weekday in weekdays. So we'll print 2, and mom. Next, we're going to print for each character in this word, print and then put a semicolon after it. And so it's printed all on the same line, all 4 characters, semicolon after each one, and then print it out. In other words, just print the character term. So it's going to be D colon A colon T colon A colon and then enter. Yes. Let's do one more. It's going to do, it's going to have a variable called result, and it's going to loop through all these weights, 4, 5, and 7. And each time it loops, it's going to subtract the weight from result. And then at the end, it's going to print results. So it's going to be 0 minus 4 minus 5 minus 7 is going to be the same as 4 plus 5 plus 7 is 16 minus 16. So it's going to be minus 16. All right, so you can do that. What's this one? Val count is read from input, representing the number of values to be read. So yeah, you can do this sometimes where if you know it beforehand how many values you want the thing to read in, and you don't want to use a sentinel, then you can do it this way. So we have val count is we're going to read it in, and then we have this blank, we have this empty list, and what we're going to do is we're going to read in a bunch of numbers and we're going to stick them in this thing here. Then at the end, it's going to say how many characters it has. Huh. What are we supposed to do? Oh, well, then I'm supposed to print them out. Okay, so I'm going to go list has 4 elements. Then I'm just going to go start. List has 4 elements. I'll just get rid of this. 4 element uh, 4 element. 4 element. I'm just going to call it element in paint list. Print out. Oops, got to put a colon there. Print element, comma, selected. Let's see if this is right. Looks like it's right. Okay. Let's do one more. Okay. Val count is read from input representing the number of values to be read. The remaining values are read from input into state list. Okay, that does it this way. It uses this range variable here, which this is just gonna set up something that goes from 0 up to here, but not including that. So if range count is 5, if val count is 5, then this is going to make a loop where I starts out at 0 and goes up to 4. I equals 0, I equals 1, I equals 2, I equals 3, I equals 4. That's if val count is 5. So it prints out 5 things: 0, 1, 2, 3, and 4. And so what I'm supposed to do is it reads in a bunch of stuff. Let's see what the example is. It reads in, oh, look at this. It reads in the 3, and then it reads in these 3 nice red states here, and it's going to print that out like that. So this prints out this, and now we got to print out what goes down here. So For state in state list, print. Print, first print this. Oh, I gotta do this other thing. Print F that this state, close the parentheses, close this, and then can I do this? And equals, I don't know if this will work. Is there a space in between here? No. Hmm. Wonder if this will work. Ah, worked. Excellent. Hmm. All right, counting using, okay, so I introduced you to range a little bit here. Let's just do this. So you have this range function, and usually there's a number inside there. If there's a number inside there, it's going to be 0 up to that number, not including the number. If you do like this, it's going to be this number up to, but not including this number. Say this is -7, -6, -5, -4, but not -3. If there's a third number, then that's like a skip number. It's going to go from X to Y, skipping every Z here, incrementing by Z. So it's like if you have a 0, 50, and 10, it's going to be 0, and then 10, and then 20, and then 30, and then 40. So it's not going to have the 50. If Z is negative, it's going to go backwards. Yeah, it's going to go backwards. All right. So this is how you can, this is range. This is a shortcut for iterating a certain number of times, you know, and some you can skip it every now and then. You can skip them. So you can sequence through numbers and so on. All right. Can go through these. Let's do this. Let's do some of these. All right. This 0 to 2, 0, 1. Okay, let's start this up. These are real easy. It's gonna do 0, 1, oops, 1, 2. And then it's gonna do space, and it's gonna enter. I think. Oh, oh, forget the enter. Forget the enter. Sorry. Yeah. Okay, what's next? Okay, so this is gonna do what's I times 2? 0 times 2 is 0. 1 times 2 is 2, and that's it. Because it's not gonna do 2. All right, you can do the last one. This one is positive number, reads in a positive number this, and then it's a number of tripods. Then it does do a range to call so that the loop iterates through the increasing sequence of all non-negative integers less than numpods times 3. Non-negative integer. So it's going to start out at 0. It's going to start out at 0. And it's going to go all the way up to num tripods times 3. I think this should work. Oh, that's easy. Oh. Anyway, yes, easy peasy. What's next? Positive integers are reads in batch low and a batch high, representing batch number assigned a collection of data. Complete the iterate decreasing sequence of all integers between batch low and batch high exclusive. Okay, so that would just be in range batch low, batch high. And it's going to be exclusive and inclusive. I think that might be all. Yep, that's easy. So it'd be it's decrementing now. So we're gonna do the loop variable is called catalog val. It's going down. Catalog val in the range of catalog start down to catalog stop. -1, but we want to include catalog stops, so I'm going to do -1 like that. See if that works. So I want to include both inclusive. Yeah, yeah. Okay, we'll see if this works. Yeah, yeah. So we got to put that -1 there because we want to include that one, because normally it would just skip the last one, and we want to also include the last one. It's going down, so that's why we want to go down one more to make sure we get it. All right, so the last section here was 302. Well, deciding when to use for loops and when to use while loops. You can read through this. A loop combined with range is generally preferred since loops are less likely to become stuck in an infinite loop. It kind of protects you against yourself. Programmer might easily forget to increment the loop's variable. It's called an infinite loop. General rule of for loop, iterations, while loop. Well, anyway, that's it. Okay, so I'm going to end it here, and I'm going to do the exercises in a different video probably between now and next time. Okay, so thanks for watching.